Okay, P8.4, moments at work. So what we're talking about with moments is so a moment, and to give it its full name, is a turning moment. And people get confused by the word moment because they think of like a moment in time or something similar, I don't know. But all you're thinking about is a turning moment. And what it's doing is it's causing something that's causing a turning effect. So if you imagine that you've got a seesaw and you put a weight on one end of your seesaw, then this seesaw is going to go down in that direction, and that would be called an anti-clockwise moment, because you're turning it, you're creating a turning moment in the anti-clockwise direction. Now if you put a weight on this end, this one is going to be causing a clockwise moment. And you can work out how big that turning effect is by using the following equation. So that's my force. That from there to there is my distance from the pivot. So the equation is simply moment equals force times perpendicular distance from pivot. And all that means is how far at a right angle. So if you look, this one is at a right angle, so that's fine. That distance is just the distance from there to there. Where you have to correct that is if it's at an angle which isn't perpendicular. So it's the perpendicular distance from the pivot. Okay. And the main thing you need to understand about this is moments. So, for example, if I put a spanner which has only got a short handle, if I want to turn this nut and I give the spanner handle a force in that direction of 100 newtons and it is a distance of 0.1 meters, so my perpendicular distance is 0.1 meters. So that means that my moment equals force times distance, which is 100 times by 0.1, which equals 10 Newton meters. Now that might not be enough to loosen this bolt. If that bolt was really stuck really hard, I would need a longer handle. So now I've got my long handle spanner, and this distance here, that is 10 meters, really long handle spanner. And I still apply the same 100 newtons that I did before. So my moment is still force times distance. But this time my force is 100 newtons times by 10 meters. So that means that my moment is now 1000 Newton meters. So the turning effect that I've created is far greater. So out of the two examples, the nut that is going to become loose first is this one. Okay, I'm creating a higher turning effect than I am on this one, because this one's only got a short lever. So you can increase the moment by making the lever longer or by making the force longer.